Hi everyone, Professor Bob Young here, and in these first few instructional videos, we're going to be discussing basic terminology of equations, solving linear equations and what they are, identities or types of equations, and solving formulas for a specified variable. So let's go ahead here and look at a few things. And first, let's talk about equations. An equation is a statement that two expressions are equal. For example, x plus 2 equals 9, 11x equals 5x plus 6x, x squared minus 2x minus 1 equals 0. Many of you have seen these type of creatures before. So to solve an equation means to find all the numbers that make the equation true. The numbers are called solutions or roots of the equation, most often solutions. A number that's a solution of an equation is said to satisfy the equation, like Wrigley Spearmint Gum, chewing satisfaction. So the correct solution satisfies the equation. Equations with the same solution set are called equivalent equations. So there's a few properties we want to talk about next in chapters involving linear equations, and the first is called the addition property of equality. So let's take an equation here, and I'll take something easy to start out with. Let's say 5 equals 5 here. Now, if I go adding 3 to one side of the equation, since they're equal, it makes sense that I must add 3 to both sides. So Young says whenever you're solving equations, there's 2 letters to always remember: BS. And you'll hear a lot of that in this course. But what BS means is whatever you do to one side of something equal, you must do to both sides. All right, now also students get confused here because what if I said 7 equals 7 up top there, and I go subtracting the same number from both sides? Now that still makes them true, and there's not a problem there, but students don't realize this is also called the addition property of equality. There is no subtraction property. And I know what you're saying is, why, Young, why? Because there's a little rule for subtraction that says this: if you have A minus B, any two things subtracted, you can rewrite that as A plus negative B. So any subtraction statement can be rewritten as an addition statement. So we could say the 7 minus 3 over here is 7 plus negative 3, and just add negative 3 to both sides. So really the addition property of equality covers both addition and subtraction by adding a negative. So keep that in mind. There's only really 2 properties we have to worry about when it comes to equations. And here is the other one, the multiplication property of equality. So let's take a true equation here, 10 equals 10. Now, if we go multiplying both sides by 2, we'll get equivalent equations. All right, they'll have the same answer, so we'll have 20 equals 20. So again, whatever you do to one side, BS. Now, if I took that same equation and divided both sides by 2, that is also considered the multiplication property. There is no division property. I know some of you are going, how can you call that multiplication, Young? Because there's a statement for division, and by the way, this is called the definition of division, that says if you have A divided by B, you can write any division statement as a multiplication statement by writing A times, guess what? Wait for it, the reciprocal of B. A times 1 over B. So notice over here, we would get 5 equals 5, but we could have also said 10 and multiplied both sides by 1/2 instead of dividing by 2 to get the same statement. So on the multiplication property of equality, it encompasses both multiplication and division, since you can write division as multiplication. So only 2 properties to deal with in this section. All right, now here is the real basic definition of a linear equation in one variable. It says a linear equation in one variable is an equation that can be written in this form: ax plus b equals 0, where a and b are real numbers with a not equal to 0. Because if a was equal to 0, let's face it, you would just have b equals 0 there. So we could put all kinds of numbers in there and will. So let's continue here. And one other thing to talk about on linear equations. Now, when we start getting deeper into the course, we're going to find that these are graphs of lines. Notice they have the word line in them. Why don't they just call them line R equations? But what a lot of students don't realize is that a linear equation is first degree. All the variables in a linear equation are of degree 1, which means that the x is always to the first power. So notice in all of these examples of linear equations here in the first row, all x's are to the first power. Now, and notice in the second row, these are called nonlinear equations. Now, why, Young? Well, the square root of x, if you remember from previous courses, can be rewritten as x to the 1/2 power. It doesn't have an exponent of 1. It's not first degree. The second example, 1 over x, is x to the negative first power. So it's not degree 1. And obviously, this third example, you can see something with an x squared in it is certainly not going to be linear, and they won't be graphs of lines when we get to those later on. All right, now continuing here, this is the handout in your care package, and it's probably in Angel and other places you can get to it. I'll give it to you if you're a lecture or hybrid student. If you're an online student, you'll find it in Angel or one of the other supplements there. I'll tell you how to get to them. You'll see course supplements to go with everything. And this one's entitled Solving Linear Equations, and here's how to do them all right here. Step 1, clear fractions by multiplying through by the LCD, or clear decimals by multiplying through by 10, 100, 1,000, depending on the greatest number of decimal places in any given term. Now, this is using the multiplication property. So this is what allows us to get rid of fractions or decimals. Okay. Step 2, distribute. Get rid of those parentheses. Step 3, collect like terms, and I always like to use these 3 letters for that, CLT, and notice I throw in a little humor here, TLC, tender loving care, collect like terms with tender loving care. And then what I like to do is say move all variables you are solving for to one side, so I like to call this 4th step letters left, numbers right. Okay, and notice that down here on the bottom, I made a mistake in here. This should be an N, numbers right here. Okay, and that's using the addition property of equality that's going to allow us to move the letters to one side and the numbers to the other when solving linear equations. And then, of course, solve, and then check your answer. So we're going to do some examples now. And notice we don't always have to use all 5 steps on that previous handout whenever we do something. Look at this example here. There are no fractions involved, so we can bypass step 1. We don't have to worry about getting rid of the fractions. So in this case, we're going to go to step 2, and we are going to distribute first to remove the parentheses. Because Aunt Sally, if you remember order of operations, will always say multiply before adding and subtracting. So that's what we're doing even with polynomials here. Okay, and notice in front of this second parentheses on the right, it just has minus the quantity x plus 5, but really there's a -1 in front of that second parenthesis, so be careful there, watch your signs, and notice there's a huge thing here, watch the signs. Signs are killers in algebra. So multiplying the 3 through, we're going to end up with 6x minus 12, and then distributing the minus over here, notice changes all the signs in that second parentheses. All right, combine like terms. Now really the only like terms there are here, and I love to use colors, is the 7 minus 5 on the right there gives you 2 minus x. And then they do the letters left and numbers right. So what I like to do here is I like to kind of isolate this step right here and save you all a little time doing them. So what I do is I'll put a little LL here by adding x to both sides of the equation. So to undo subtraction, attack with addition. And if you do it to one side, BS, both sides. Similarly, the numbers, you've got to take right. So to undo a minus 12 and get that minus 12 moved over to the right, we're going to hit him with plus 12. And if you do it to one side, BS. So this equal equal sign is a little like divider here of things you must do to both. So notice when I do that, now I have saved the steps and I'm all the way down to this step. Now, of course, since this is a graphic, they went ahead and they added the letters and they kept everything going left to right there. But I like to just line things up like that, so it makes it easier for me. So solving for x, we get x equals 2. Now, here's what I love about equations, y'all. You can take that 2 and watch what happens here. Here was our original problem. We're going to take that 2 in pretty blue here, and we're going to stick it wherever we see an x. And notice when we do, if we do the arithmetic correctly, we will get a true statement. So that 2 satisfies the equation, and we know we did it right. So on a test, you can never miss one of these because you can plug back in. Y'all have calculators, and it's great. All right, one last example, and we'll conclude this first section on solving linear equations. Now Young's taken one that's got everything in it. You've got to use all 5 steps of the handout here. All right, so step 1, multiply through. Now, see, here's where your calculators, ladies and gentlemen, are not going to help you whatsoever. If you don't know what the LCD between 3, 2, 4, and 3 is, you're in trouble. Now, you have to know it's 12, so we're going to take and multiply each term by 12. So terms are separated by plus or minus signs. And what I like to do and tell students is to take that 12 and stick it right next to each fraction. So when you cross-cancel, or chop-chop as I like to say it, you can get rid of those fractions. All right, and I'll use some pretty colors here to cross-cancel and chop-chop. So 3 goes into 12 4 times, and notice that's what we have here. All right, 2 goes into 12 6 times, and we have 6 times t. There it is. And then over here, 4 goes into 12 3 times. There's your 3t. And then 3 goes into 12 4 times. Now notice here we have the 4 times 7, and that gives us 28. So then step 2, distribute, multiply the 4 through. That gives us the 8x plus 16. Collect like terms. Now let me use another color here. I love these colors here. This is great. 8 and 6t is 14t. Okay, equals 3t minus 28. Now in the next graphic here, we're going to go letters left by subtracting 3t from both sides. Numbers right, subtract 16 from both sides. So again, whatever you do to one side, do it to both sides. To undo addition, attack with subtraction. To undo subtraction, attack with addition, and so forth and so on. So what we'll be left with is 11t equals negative 44, so t will be negative 4. Now, even with one of these beastie problems with fractions and so forth, you can check that answer by taking that negative 4 and putting it in wherever there was a variable. And notice you will get a true statement. So in summary, whenever you solve linear equations, looking for the handout, sorry. 1, make sure you clear the fractions and decimals by multiplying through by the LCD. 2, distribute, get rid of the parentheses. Collect like terms, go letters left, numbers right, and then solve and check your answers. So this is Bob Young signing off with your first instructional video.